Hello, welcome. We're going to learn about dependent t-test today. You know what today is? It's graduation. And so I just have a few minutes to spare before it's time to line up. So why not make a video on dependent t-tests? And I thought also maybe it's motivating for you to understand that watching this is just part of getting there. It's part of taking those steps for you to get to graduate and for you to be Dr. whoever, all right? So let's talk about dependent t-tests, how you would write this up. So let's pretend you want to know if students grew from the fall to the spring on some kind of benchmark, all right? So let's say the benchmark is in reading. Now, the way this is set up in the data set, we are looking at how each kid, we're going to look at the scores from each kid, and they're going to be all lined up in a row, and we're going to compare them. It's not a good idea to look at their game scores. Instead, we're going to look at how they changed over time. So, my research question is, and this is written very specifically, is there a difference between fall reading scores and spring reading scores among this related sample, okay? So my null hypothesis would then be there is no statistically significant difference. And I've got to remember, what's the logic of what I'm doing? So when I conduct this, when JMP does the math and does the formula, it's basically going to churn out a T, and it's going to say if this T would be really rare to find, or if that's what we would expect from a null hypothesis population. So the null hypothesis would probably be, hey, the T is 0. There's really no differences between time 1 and time 2. But it would be really rare to see a big difference, for the T to be big, and it would fall above, like over on this side or on this side, depending on the degrees of freedom. And it would be really rare that I would find such a big difference due to chance, all right? So I've got to think about my sample and what I should set my alpha to be. And this is a smaller sample, so I'm going to set the alpha at a 0.05. Now I've got to walk through my assumptions for a dependent t-test. And these are a little different. So first I have to assume, oh, there's a phone. Hang on a second. Let me pause this. All right, back to where we were. So first we have to assume that our sample is random and independent. And so I'm going to assume that for most of our homework assignments. You need to think about that with your sample. And we have to assume normal distributions, but this time is normal distributions of the differences, the different scores. So remember, in your computer program, you create a column looking at the difference between time 1 and time 2, and then you look at the normal distributions of that column, of those differences. And for this data set, the skewness was between -1 and 1. For those differences, so I'm going to assume normal distributions. If it was above a 1 negative, if it was not between -1 and 1, I would look at kurtosis and to see if kurtosis is between -2 and 2. All right, so then moving on, I need to look at equal variances. Now remember, for dependent t-tests, I am looking to see if the standard deviations between time 1 and time 2 overlap. Do you remember how standard deviations are the square root of the variances? And so standard deviation is a measure of variance, and I want to make sure that they are within, that they overlap, and that we can assume they're close to each other. So I'm looking at between 15 and 22. Now, does 10 and 15 fall within the range? Okay, does 10.47 and 15.82 fall between the range of 15.04 and 22.74? You see? Well, the answer is just barely, just barely between 15.04 and 15.28 do these overlap if I drew these lines out. So I can assume equal variances. Now I conduct the dependent t-test of matched pairs on J and P, and I find that yes, indeed, there is a difference. And if I have a non-directional hypothesis, if I just said I'm looking for differences, I look at this p-value right here, and this is the t-value that I report, and I report these degrees of freedom. And I'll show you that in here in a minute, how to write it up. Now, to determine, well, how big is this difference? I need to report the effect size. And to do that, I'm going to go to this calculator, and I'm going to go to the calculator for within groups. Within groups is another word for repeated measures, which is another word for paired tests, which is another word for dependent t-tests. Okay, so when I'm looking within, I'm looking at the same group of people, so I'm looking at differences within that group. All right, so I'm typing in the mean of group 1, the mean of time 1, and the standard deviation of time 1. The mean of time 2, the standard deviation of time 2, and here I put the correlation, which is here, between these two time periods. I hit calculate, and so the Cohen's d is a 0.47, which is considered moderate. How do I know that? I look it up in the Hatcher book. So when I write this up, for homework assignments and that kind of thing, I'm going to report skewness. You would not do that for your dissertation. You would just say that assumptions were resolved for both normal distributions and equal variances. I'd also write for homework, equal variances were assumed because the 95% confidence interval range of standard deviations overlapped. All right. Then I would report my findings from the t-test. I would report significant differences, statistically significant differences. Notice I use the word statistically significant, and I have the means and the standard deviations. Notice that the M and the SD are italicized, and have the T. Hey, what's this number here? That's the degrees of freedom that I had up there. This was my t-value, negative 0.23. Remember, that comes right from this right here. That's where I'm getting these numbers from, and this is where I'm getting my p-value. All right, so I'm looking at the t with the lines. All right, so and then I have that these differences are considered moderate. These are pretty decent differences here, so report that. Now I would, if you were only looking at one level of scores, I wouldn't make a table necessarily, but if you did make a table because you were looking at not just reading scores, but you were also looking at another row of math scores and another row of science scores, and you have lots of data, it would be good to create a table. Now remember, these are not necessarily an APA because on Google Docs, I'm not sure how to do that, and it's really for you to figure out, but you would never have what kind is this? Vertical lines on a table. So you would put how many were in each group. Oops, I got to go back and look at the data set, but it should be the same because we're looking at the same group of kids, okay? You put the means, standard deviations there, degrees of freedom, T, and the P. And actually, I should have here M. All right, so that people understand what these numbers are. And these will need to be in italics because that is what APA wants, okay? So that is a dependent t-test. And actually, I don't think degrees of freedom are italicized. That could be for you to look up, but I don't think it is. The T and the P are definitely italicized. I have this noted with an asterisk because it is indeed statistically significant at the 0.05 level. So that is how you write a dependent t-test. And next will be ANOVA. Y'all have a great day.